Hi, everybody. Can everyone hear me? Okay, let's see what we got. All right, chat log. If you guys can hear me, say yes. Anyone in chat? Because I can't see the chat at the moment, which makes an AMA somewhat problematic. There we go. Okay, we're good. I'm in the mountains of Switzerland right now. I'm actually over in St. Moritz. I'm here for a conference. I just flew in from Zurich. I went from London to Zurich and took a 3-hour train ride to come on down and to enjoy this nice conference. This is one of the few places of Switzerland where you're bound to hear more Italian than you are French or German. Uh, I just got back from a major summit in Berlin not too long ago, and I wanted to make a video recap of some Shelley related stuff and some news about that workshop that we did internally, and also some releases upcoming. And then I wanted to open it up to the floor and get some questions from you guys. So anyway, hopefully this won't be too long. I know I'm notorious for long things, but it's 11:31 at night, and I've been traveling, so I'm a little tired, but we'll get through it. Okay. So first on the list is kind of a recap of the workshop that we did in Berlin. So first, there was a bit of a misunderstanding of what this workshop was about. It was not a public event. We received apparently some criticism over Twitter where people are saying, "Oh, well, we saw pictures that you guys took, and it wasn't not many people showed up." Well, 100% of the people there were partners of our company, like our Merco people, or work for me. So no more or no less than necessary showed up. The purpose of the summit was to discuss the formal specifications that we've been writing for Shelley, in particular, two formal specifications. One is the delegation specification, and then the other specification is the formal ledger specification. So generally, when you have a cryptocurrency, the rules of how that ledger works are incumbent and implicit within the reference implementation. So, for example, if you're in a UTXO system, this notion that the amount going in the inputs has to match the stuff going in the outputs. And if there's a mismatch, you're either creating new coins or you're giving mining fees. That's a notion of something that a ledger rule would cover. And so you can extract ledger rules from an implementation. Like it's a perfectly legitimate thing to do to read the Bitcoin client and say, okay, these are the ledger rules of Bitcoin, or these are the ledger rules of Monero. So it's kind of the rules of the game. It's almost like watching some people play poker, and then after you watch them play for a few rounds, kind of inferring, well, I think I know how poker is played by watching them. The other way to go around it is to write the instruction manual for the game. And because of the nature of what we're doing, that's probably the better route because there could be some nuances missed if you're just covering a particular implementation. So anyway, we wrote a formal ledger specification and fully describe how the Cardano ledger works right now. So that's the old ledger spec. And we are describing how the ledger needs to work for Shelley, covering all the features that Shelley's going to have, like multi-asset accounting. So when you issue assets, how can you track multiple assets at the same time? Extensions to the UTXO model so that we can actually implement Plutus and Marlow into the system, amongst litany of other little features, like, for example, the notion of preservation of value, where you can always track units of ADA, unminted ADA, minted ADA, ADA in the treasury, ADA that's due to be paid for rewards. So you can write property-based tests against that. So that was one major document that we covered, and it was really important to go through that document for completeness, but then also for accuracy, and then finally for simplicity. It's a really good idea when you write a specification to try to simplify it as much as you can, remove unnecessary rules or get rid of redundancies and so forth. And the only way to do that is what's called a red team, black team model. So basically, the concept is one team, the black team, will write it, and then one team, the red team, will read it, criticize it, try to find problems with it, and be the adversary and challenge every design assumption. So the workshop basically gave us the opportunity to do that. People from IOHK Science were there. Peter Gaji was representing them. And then we also had engineers from the Haskell team and engineers from the Rust team, as well as engineers from Emergo, in particular Sebastian and Nico, because they're actively maintaining your ROI, and they're going to need to understand where the ledger rules are going for Shelley to ensure that your ROI has interoperability. Okay. So the other specification that we were covering, and the one that's probably more meaningful to the vast majority of you, is the delegation specification. And basically, that describes how staking is going to work under the hood. When we first designed Cardano back in 2016, and we were building it throughout 2017 with our initial engineering effort, we kind of had this idea that delegation would be something that could be done iteratively, where we would have a very simple, easy design that almost looked like certificates, like web certificates, the X.509 standard. And you just post them on a blockchain, and with some modification, everything would just kind of work its way through. This kind of showed our naivety, and it was something that caused quite a bit of delays for us historically, because the moment that we started getting deeper into that concern, we realized that it's probably the richest and most significant component of a proof of stake system. It's not good enough just to define what is a ledger and what is an epic and how slot leader elections work and where randomness is going to come from and prove that you have nice security properties. It's much more meaningful to talk about how do you move allocation of control from the base state to a different state, and do that in a way that is user friendly, and do that in a way on the types of devices that people are going to want to use, from cold devices to mobile devices, to other actors in the ecosystem. You have to have an opinion, like, for example, exchanges. When you hand a stakeable currency to an exchange, because they control the private keys, implicitly the exchange is actually controlling the rights behind that currency. And you have to build special accommodations if you want to exclude them from that. So throughout all of 2018, we were working very diligently at trying to parse down all the trade-off profiles and consequences of these business requirements. And about the middle part of that year, we eventually converged to a design we were happy with. The problem is that you have to build it, and to build it, you need a spec. So we handed that design document to the specifications team at the Formal Methods Group, and Phil Kant, Jared, Lars Brunias, Duncan Coutts, and others spent a considerable amount of time generating the delegation specification. It took a long time to get the spec to a readable, complete state. And the workshop also acted in that red team, black team model, where for the first time, the engineering teams were able to go through it in incredible detail, excruciating detail, and vet out the specification to a point where we actually now know all the nuances of it, to a point where we can build it. Okay, so the advantage of this specification process is that the spec, while written in math, is very close to a canonical representation in Haskell, meaning that we can go very easily from math to kind of a lightweight reference version of the software. And we've actually done that for most of the specifications, both the formal spec. If you look at the GitHub formal spec repo that we have at the IOHK GitHub, you can see that. And we've also done this for delegation. Now, the advantage of this setup is that by having a reference code, not only do we have an opinion on how it should be constructed, a very rigorous way of writing down those instructions, and that's useful for testing, you now have a reference point that you can A/B test against the commercial implementation to verify that the commercial implementation is bisimilar to the specification. This is the highest standard of engineering. It's very difficult to do this. It's done in aerospace engineering. It's done a lot when you're building satellites or the Mars rover, and for good reason, because these systems, once deployed, are expected to operate autonomously or semi-autonomously for long periods of time. And if there's a bug, you can't simply go retrieve them and fix them. They just go offline, and you've lost the probe or lost the satellite, and that can cost billions of dollars. So you need assurance that there's a very high probability it's going to work the first time when you flip on the switch. Furthermore, because of the nature of these protocols, they're cryptographic protocols, they do require security auditing once they've been implemented. And it's extremely important that the auditor fully understands the intentions of how the system was to be constructed, in addition to how the system is constructed. It allows them to get a much richer, deeper audit, and provides a much higher degree of assurance that you've correctly implemented the system according to your intentions, not just that the code itself doesn't have obvious defects like side channel attacks or so forth. So anyway, that was a big milestone for us. It's the first time as a company that we've done it. We did it in a smaller group internal to the wallet backend team with the UTXO specification, but we've never done it on a company-wide scale for multiple teams, including external vendors. And we're really excited that we were able to bring everybody together. And the conversations were incredibly deep. But what was really, really reassuring about them is that there were only minor changes that needed to be made to both the ledger specification and to the delegation specification. So that's uh, that's just a great thing. Whenever you walk into something and you have a professional team of critics, and a lot of them are really smart people with PhDs, and they're pretty aggressive when they're asked to be a proper peer reviewer, and they give it their all, and they don't find too many issues. So a natural question to ask is, well, where are we going to go from here? And how do we get to Shelley? What's the bridge to Shelley? So we're retiring Byron. In fact, 1.5 will be the end of life update to Byron. And it's both a Shelley update, so it's the very first Shelley update, and it's the very last Byron update. So excluding the hotfix we're shipping soon, 1.4.1, which corrects a few of the lingering issues from 1.4, 1.5, the users won't immediately notice any difference. There are no material changes being made to the wallet backend, and no material changes being made to any features. So you'll install it, but nothing will happen. It'll just be like your normal wallet. But under the hood, what's happened is we've stripped out the classic Ouroboros implementation, and we've replaced that with Ouroboros BFT. Now, this is the first step in the road to Shelley. How Shelley is going to work is there's going to be a series of iterative updates that will first put core infrastructure in place, and then it will put basically a process into place that will gradually decentralize the network epoch by epoch. So the first infrastructure piece is Ouroboros BFT. The next infrastructure piece is going to be 1.6, which will ship the decoupled wallet. And so if you look at our repos right now, you'll see a repo that says Cardano wallet. And we're almost done with this. What's going to happen is we've taken the Cardano wallet that we currently have, which was coupled with the backend Cardano SL repo, and we've torn it out and made it its own standalone software product that can, over a service, connect to the core. Now, as an end user experience, nothing should change. You won't actually notice anything with that, but that's actually a very powerful abstraction. This modularization means that we can now connect that wallet backend to different code bases, to different implementations. We can connect it to Yormagon, which is the Rust client. That's the name for the Rust client, the code name for it. We haven't gotten a product name for it yet, but Rust Cardano. And we also can connect it to the new Haskell code. So 1.6 will be about getting us Icarus-style addresses and getting us the decoupled wallet. Now, the next update will be taking the Rust client that we've constructed and taking the Haskell client with the new code. If you look at our repos, that's Cardano Chain and Cardano Network, which will replace the deprecated Byron-based Cardano SL, throwing away SL and putting in Cardano Chain and Cardano Network into that wallet backend. Now, what this basically means is once that's done, 100% of the legacy code will have been basically thrown away, completely replaced with all the new code, which has been designed with a specification-driven effort. The other thing is that these ledger rules that we're implementing them in almost like a ledger DSL, right? Like ledger spec. It's easy to add and take away, and it's very easy for us to iterate up to any design we want. So once this new code base is installed, it's going to be a fairly straightforward process to put on all the Shelley-related logic. Where it's heaviest is on the address side. Instead of having just a single address for a spending account, now you have this idea of having to track both a spending key and a staking key. And you can actually segregate these things. For example, in the case of cold staking, you'll be able to take a spending key, put that spending key on a ledger device, use the ledger device to generate a transaction to create a staking key, and then you can import that staking key into Daedalus. So Daedalus can have the public key of that spending key so it can track the value behind it. and it can have the right to delegate, but it doesn't have the right to spend. This is what allows you to achieve cold staking. So your spending key will never leave the hardware device or the paper wallet, but there'll be a management infrastructure within Daedalus that allows you to basically manage the staking rights and move them around. And if you really want to escalate and import those private keys, if the device allows you to have the keys leave, it's device dependent. So anyway, these are very complicated addresses. And in the case of exchanges, you actually even need another address. We call them enterprise addresses in the specification, which says if it's in an enterprise address, it's like the ADA doesn't actually exist. It's not in distribution, and it has to leave the enterprise address to re-enter circulation. So if 30% of the ADA, for example, is sitting in Bittrex and Binance and other places, and they're in enterprise addresses, it's as if there's 30% less ADA in terms of command and control. So in other words, exchanges won't participate in staking. They won't have control over the network as long as you're sending it to an enterprise address. But that has to be cosmetically different and so forth. Well, there's a very rich discussion we're having right now about, well, what should we do with the address format? And also, what should we do with metadata, and when should we introduce metadata? So careful readers of the Y Cardano paper will recognize that for 3 years, it's been a goal of ours to associate some notion of metadata with an address. And really, the first entry point in this is the delegation component, because when you register a stake pool, there needs to be metadata associated with the stake pool. Who is the pool? There's a notion of a ticker name so you can find them, a description of the stake pool. For example, maybe you want to embed a URL so that you can pull some data off of a website, bring it into Daedalus, so you'll be able to actually read more about what is the purpose of this pool and so forth, or even simple system level parameters like how much does the pool charge and these types of things. But going above and beyond that, when you look at arbitrary transactions like Alice and Bob, uh, Alice isn't sending money to Bob just because she wants to send money to Bob. Some cases that's the case, but usually there's some sort of intent that's embedded within that transaction. Like, I'm buying something, I'm donating money with this understanding of its use. I'm prepaying a service, like you're mowing my lawn. So there's going to be a way at some point to embed intent into the transaction. And this can be done with a variety of tools. The simplest would be to take the terms of the transaction, hash them, sign them, and include them as an attribute to the transaction from the sending side. So that if somebody wanted to show up later on in a court of law or as another venue out of band, they would be able to prove in a time-stamped, auditable, immutable way that that was the intent of the transaction. I meant to donate. Here's the contract. The hash matches that, and so forth. And you can even create a system where you have interactive protocols where not only does it arrive, it's signed by both the sender and the receiver. And this is the magic of Marlowe and Plutus. So a lot of these things involve some degree of complexity around the richness of the semantics of the scripting language, but as well as the address structure itself, about how much data can we store in there, what types of attributes can touch the addresses. So one of the reasons Shelley took so long to get us to that point is that we realized that we needed to abstract our design process in a way that things were very modular and it was easy to hook things on. The price you pay for that is that you have a bit of complexity creep, and the price you pay for that is that by reducing the simplicity of the system, you have more potential attack vectors in the system. So you have to be in a very slow, methodical, systematic process to get these things through. So anyway, 1.6 is about the decoupling. 1.7 will be about verifying that both the Rust and the Haskell new code works with the system. And then the next upgrade will simply be putting in all the delegation mechanics and other Shelley-related features, like a mass update to Daedalus, which includes the delegation center, and it includes the registration process and all these other things so that you can actually begin staking. Now, how do we build up stake pools? Well, there's a parallel effort on the Rust side of trying to get basically a fair representation of the Shelley specification done as quickly as possible so that we can have a command line client to begin the buildup of staking pools. I mentioned earlier that we have this concept of gradual decentralization. So there's two sides to that. One, you have to have an opportunity for people who want to run stake pools to have a fair shot at getting them somewhere, learning how the software works, getting their Docker image or whatever their container is set up, figuring out how to deploy it on a host or self-host, getting all that stuff done. So there has to be a burn-in time for that. Second, you have to have some time for that to propagate throughout the Cardano ecosystem. People have to market, they have to brand, they have to go and make pitches about why are they great and so forth. So our hope is to get the Rust client sometime in February to a point where we can launch a test net where that process can start. So basically what will occur is you'll have two parallel efforts going on with basically two separate teams. One is about getting that core infrastructure constructed, verified, and there are going to be a series of gradual updates starting with Ouroboros BFT, decoupling, and then verifying the new backends work. And then the other effort will be getting that hook set up for expert users who want to run stake pools to actually start doing that, getting used to that, understanding that, and then upgrading and iterating that to a point where it now perfectly replicates the user experience that we anticipate with Shelley. Then there'll be a merger between the two. Our hope is 1.8. And that merger between the two will be when staking will go live in the system. It's because it's a new protocol. No one's ever done this before in the history of the cryptocurrency space. It would be pretty crazy just flip a switch and say, oh, well, congratulations, here you go. We need to have a gradual decentralization, but this can be expedited. The easiest way of doing that is recognizing that we already have a pretty cool unit of time for our system. That's an epoch. And that currently is 20,600 slots. So what we can do is take the Ouroboros BFT Federation and say, okay, instead of making 100% of the slots at time equals 0, epoch equals 0, Shelley, it's only going to make 90%, for example. And then next epoch, it'll only make 80% of those slots. And then next epoch, it'll only make 70. And it'll just keep winnowing its way down until it gets to a critical threshold. And then the entire network, all the slots are made by the stake pools. This creates a nice control valve in the system in case something we didn't anticipate or a major error occurs or some sort of catastrophic failure happens or there's a small coordinated malicious minority that's trying to do something weird. You kind of have a mechanism built in to gradually work our way up. The other thing is that it gives us a great way of also giving people who need a little bit more time to get into the staking game a fair shot at that. It's probably going to be a distribution where the expert users who are really passionate and involved are going to get in first, and then less experienced users who come in a little bit later would say, oh, well, I want to play too. And if we try to get everything in all at once and all slots made all at once, it's likely that we'll see an oligarchy form. So anyway, that's kind of the gradual plan. So we'll write a dedicated blog post as we get a little closer to it about exactly what those parameters will be, whether it's 5% or 10% or even more of the slots per epoch. Each epoch is only 5 days. So even if it was 5%, it would only take a few months. If it was 10%, it would be even faster. But the other important thing to do is to always say that the BFT side doesn't get any rewards. So we make nothing running the network, just a temporary measure to ensure security is high. And all the rewards go to the actual slot producers. So that's kind of the road. We start with Ouroboros BFT. That's the protocol that will be used all throughout the life of Shelley to get us to Shelley, decoupling, a bunch of wallet-specific features, and then from decoupling, moving on to verifying that the new Rust backend and the Haskell backend are working correctly, and then putting in the final delegation features for both Daedalus as well as Cardano itself. And then at that point, it'll be pretty straightforward to delegate. GUI scamps of the Delegation Center, we reviewed them at the summit as well, at the workshop as well. And we'll have Darko or Nicola or someone on that side write a blog post and show off some of the GUI, UX, and UI that we have. So you guys will get a pretty good idea of what the Delegation Center is going to look like. So we're pretty excited about the designs. We think they're very forward-thinking and they're well-structured. And they're also extensible, so we can add new and cool things to that. Anyway, that's That's the whole Shelley story. It's a gradual process, and now we're beginning that process this month, and all throughout Q1, things will be turning on, and then eventually you'll see actual staking occurring with stake pools, and more of those slots will be produced by stake pools, and then suddenly 100% of the network is done by stake pools. And congratulations, we're completely decentralized, and we're decentralized in a responsible, sustainable, systematic way. And we're also decentralized with the way that allowed everybody to participate because they had a bit of time to think about, well, how to run this stuff, how to test this stuff, how to get these things going. So that's the best I think anybody could do, given the nature of what we're trying to accomplish. It's important to understand that this is not a fork of existing software. This is completely new software. These are not modified protocols. These are completely new protocols. There have been over 40 papers written for Cardano, more than 20 of which have gone through peer review. So about half of them and more are going through peer review at major conferences. And this is original science. So we have the dual disadvantage of being the first mover with new ideas, which always means there's going to be a suboptimal result, and the dual disadvantage of not having a reference code base to look at. Had we forked Bitcoin or Ethereum, we would have all the lessons that they've learned over the 10 and 4 years, respectively, to leverage from. In this case, we're doing it basically all on our own. And despite that, in about a year's time, we were able to get a product in market, get over 100,000 users, build multiple implementations of that product, get it listed on more than 25 exchanges with a huge list of ideas about where to go, not have a major security event, knock on wood, develop an auditing process, a QA process, a help desk process, which has answered, I think, more than 50,000 tickets, and be able to move completely to specification driven development for the core components of the system. And those specs will be publicly available soon. As with all things, they have to go through a little bit of a release process just to make sure they're all cleaned up and make sure the language is polished. And we didn't leave any comments or other things that would confuse people that were just there for the workshop, for example. And then you guys can be our red team in addition to the one we had in the workshop and verify that those things are okay. Now, there's also another side of things, which is the feature richness. Where are we going to go? Because Shelley's exciting, but by no means is Shelley the end of the road. Shelley's just another major milestone on getting us where we need to go. Well, Jared, the principal architect of the specifications, will be throughout this month and the next updating the ledger spec and the UTXO spec to reflect the reality that we're deviating from normal UTXO to what's called extended UTXO. This is a requirement for Plutus and Marlow to work in our system. So we kind of have this beautiful team that's working on something called a mock chain. So it's kind of a fake blockchain that they constructed to test out and verify that their smart contract language works. But at some point, we have to run Plutus on a real system. So the Plutus team is coming to a 1.0 milestone. Plutus Fest basically showed off Plutus to the world, to the general PL community, and we've gotten great feedback from that. Now people using Plutus Playground are actually able to build things, and we recently even saw a course launched on how to use Plutus by members of the community. So that was a huge milestone and a great success for us. But there needs to be a kind of a methodical movement of Plutus into our system. And that's going to be done by updating the specification to reflect that with an extended UTXO model. The advantage of the approach that we've taken is it turns out that this extension is rather mild compared to delegation. So it can be quickly added into our ledger post Shelley, and it's not something of that scale or complexity. Most of the scale and complexity was in the language design. And it's really a four-layer model. So you have Marlow, Plutus, Haskell, and then there's infrastructure that Haskell code needs to run on. And we've begun scaling up resources on both WebAssembly and JavaScript for GHG.js to be able to take Haskell code and convert it into JavaScript, take Haskell code, convert it into WebAssembly, meaning that you'll be able to actually run the client side of your smart contracts in a containerized environment, whether that be within Node or be within Chrome or Firefox, for example, for web applications or for Node packages. So this is pivotal or adapt model because basically it says if you're dealing with domain experts but are not experts in programming, almost kind of like the Excel model. You're talking about accountants and people who like spreadsheets, but they're not really hardcore programmers. Give them a logic that allows them to solve that set of problems. If they're programmers, but they want to live within a certain environment, that's what Plutus is all about. But when you go outside of that environment and go to a more general environment, either directly on the metal of the system or within some sort of VM like V8 or WebAssembly, then give them the Haskell side and the GHDJS and WebAssembly side. So we can adequately cover all parts of that triangle: the server, the client, and the blockchain. This is the Plutus paradigm. Now, getting that into Cardano is not very hard because that environment's been custom built for it. The hard part is deciding what that's going to look like. And we spent 2 years of research with the best people in the field, like Phil Wadler, Memo Chavardi, and Simon Thompson, figuring that out. So we're super excited about that. The other thing is multi-asset. You may have noticed that we have this design called chimeric ledgers, and we've actually implemented it in Scala already, and it's in our enterprise framework that we've been building and running pilots with, and we're porting that design over to Cardano. The first instantiation of it will be for stake pool rewards. Unlike Bitcoin, when you set up a mining pool at Bitcoin, you have to trust the pool operator to pay you. With Cardano, we can guarantee that you're automatically paid without trusting the pool operator. And to make that work well without a lot of dust transactions, it's actually useful to use an Ethereum style account model in this particular case, rather than a UTXO model. Because of the chimeric ledgers work, we can easily move between these two accounting models and guarantee that money is preserved, no money is lost. So that's our first instantiation. An extension of that would be user issued assets for native assets. And over the next 2 months, that's what Jared's going to be working on with his team, at extending our specs so that we have that. And then we can easily roll those into the Cardano chain in anticipation for the launch of Goguen. On the wallet backend team, after we have the Icarus style addresses, the next thing in our pipeline is hardware wallet support and multisig, alongside all of the API enhancements that need to be done for Cardano, for Shelley. The V1 API set is sufficient now for exchanges, for basically the way we've built Cardano, but there needs to be specific APIs that are relevant to staking mechanics. So that API extension will be the last REST API update that we likely do. Maybe there'll be a few more that need to be in for certain things, but it's not. We're not going to stay on that model for long. Once we're done there, some subset of the wallet backend team will begin redoing the backend to include GraphQL. This is part of a broader model that we have for our application architecture for Daedalus, as well as having a more general way of assessing APIs. And then that way exchanges can have much more sophisticated granular queries. And also when we bring in the terminal into Cardano, it means that you can have much more sophisticated queries while interfacing with those wallet backends. We're also going to be moving the GraphQL for all of the IOHK product lines. So we're moving Mantis in that direction. Eventually we'll move the Rust client in that direction, and we'll do that with the Haskell client as well. GraphQL is real powerful. It can do a lot. It's a very resilient, robust system that Facebook designed. It's open source. The only downside is because it has much more power and complexity, you have to be a little bit careful about how you integrate it. And in particular in Haskell, there's going to be some friction in getting that in. So one part of the team will be involved in that in a parallel effort. Another part will be sticking with REST, and updating the V1 APIs to an extended set so that we can cover all the staking related features and things necessary for Plutus. And then going beyond that, the team will also be working on getting ledger support, the multi-account settings so that you can manage public keys, so like your paper wallets and your ledger devices, the delegation center, these types of mechanics, as well as our plans for multi-sig inside the system, both for just naive multi-sig accounts, but also multi-sig accounts that can be used for stake rights, because it gets a little hairy when you say, well, I'm moving one user controlling stake rights to multiple users controlling stake rights. How granular do you want to set those permissioning? Is it just a majority system or a super majority? What does that exactly look like? So that's what that team is going to be doing, I'd say, for the first 6 months of this year, is the decoupling Icarus style addresses, multi-sig, terminal support, ledger. That's a huge task load for the 8 engineers there, and they're real motivated and they're working really fast. And the decoupling allows them to work even faster. And then the next 6 months, we're going to be just enriching the terminal support in preparation for Goguen, because you'll be able to deploy smart contracts from the command line in the wallet. We need to be able to make sure that there's a good experience there. We learned ourselves, and we learned a lot from Mallet, the minimal wallet interface that we created for Cardano CL, and we just need to keep pushing that forward. In addition to that, that team will also be working on our sidechain support, because this will give us, coincidentally, a phenomenal light client experience. I'd argue probably the best light client experience in the entire cryptocurrency space, and for good reason. So we have these things called TMSs, threshold multisig. It's a primitive that we created in the proof of stake paper, the sidechains proof of stake paper, which recently got accepted to Oakland, which is a major cryptographic conference that IEEE puts on. It's actually one of the hardest conferences to get into. The original Ouroboros paper got rejected, and we went to crypto instead. So it's really exciting that the sidechains paper is that much better. And the sidechains paper gives us the ability to have a discussion around creation of these special representations that allow you to verify big chunks of history without having the history. This is really useful for sidechains because you need some sort of way of knowing that when you receive a foreign asset, that asset has not been double spent and that asset actually exists. But along the same token, you can look at a light client as treating its own asset as a foreign client. In other words, it can verify that when it receives a transaction, that's actually part of the UTXO, even though it doesn't have the full blockchain. So what we're likely going to be able to do is take these TMSs, use the stake pools to generate them, and embed them in regular places within the chain, in the epic, and then take that, the entire UTXO of the system, and take the Merkle root of the UTXO and put that in the block header. So basically what you'll be able to do to bootstrap is download the UTXO, check it against the hash in the header, and then verify that that's actually the correct UTXO through the TMSs, and just have the Genesis block, not the full chain. That's a super fast way of bootstrapping. It can be done in a matter of minutes, if not sooner. It just however long it takes to download these assets, which are considerably smaller than the entire chain. Then, as a background process, the chain can upgrade its way up to a full node at some point, but you'll be able to immediately begin spending as soon as you've verified that, because you know how much money you have and you have a high trust threshold of that. And it's also important to point out this is a network level phenomena. So it doesn't matter where you get served that UTXO, and it doesn't matter where you get served these artifacts. Through the magic of cryptography, you'll be able to verify that they're correct with a high degree of certainty, meaning that you get basically full node security around that, but you're only paying the light client price. So this is a huge thing for us, and it's something that will allow us to have I think, much richer user experience for Daedalus, because instead of having to be a full node by default, download the entire blockchain, and then use Cardano, you can just simply boot up, instantly use it, and as time progresses, the Cardano wallet will simply upgrade itself to a full node, but it will not interfere with your user experience. So that's a major thing I'd say for the other 6 months, along with the GraphQL work, will be getting us in that particular direction. And I think exiting 2019, this really does make Cardano super competitive, because we'll have this beautiful smart contract model that's extremely well thought out. Will be completely decentralized, and things will be running quite well. We'll have a very rich, deep wallet that's super secure. It's audited from many different perspectives. It'll have a great user experience because you can bootstrap very quickly, and basically the network will be quite resilient and quite distributed. In fact, if you look at where we're taking the staking mechanics, we feel that over time we can become 50 to 100 times more decentralized than the standard DPoS model or the Bitcoin mining model. So in the case of Bitcoin, basically 5 to 10 pools, depending on how you count things, control the majority of the hash power. In the case of EOS, it's 21 delegates. And actually, it's even worse than that because 90% of the stake appears to be controlled by about 1% of the actors. So your Gini coefficient works against you. Now, some people are concerned about fairness, and they are concerned about the egalitarian nature of systems. And there's an open question of does this rule by plutocracy and proof of stake yield a worse outcome than the rule by merit in proof of work? And so we actually have a paper on this very topic, which will be coming out soon. I tweeted the abstract and the author's set, but we actually create some mathematical modeling and try to get a deeper understanding of this. And our conclusion is that if proof of stake is parameterized correctly, proof of stake can actually be a much fairer system than proof of work, apples to apples comparison. And if you're curious about why that's the case, the paper will actually explain that in pretty good detail. So not only will we have this beautiful system that is completely decentralized and very resilient and easy to use with lots of great crypto in it, we also will have a system we feel is just simply better than Bitcoin in every appreciable dimension. Yet did borrow a lot of great concepts from Bitcoin and refine those concepts, like the concept of having a scripting language with very careful thought behind it so that its capabilities don't introduce security flaws, and the concept of UTXO counting and so forth. But moving into the next dimension, so if we are going to have these pools of effort, let's make those pools fair and make sure that there can't be one pool that dominates all of them. There's an economic disincentive for that, and also other concepts like the pools have to pay you if you've delegated to them and so forth. And also a system built acknowledging the realities of things. For example, HD wallets, hardware wallets, and so forth. These are nuances that didn't exist when Bitcoin was originally designed, and they were kind of patched into the system over time. And there's a wide spectrum of opinions on maybe what's the best way of handling them. With what we've been doing with Cardano is that we're aware of these innovations, so we're able to bring them into the protocol level. And as a consequence of being a protocol level construct, it makes it much, much, much easier for us to deal with them, as well as things that probably will never work their way into Bitcoin. For example, this notion of hash of metadata with the transaction, that's probably never going to come down the Bitcoin pipeline in a reasonable way at a protocol level, but we will start building those types of supports in. Okay, so one final thing, let's talk about the Daedalus DApp platform. We had a pretty long conversation about the Daedalus DApp platform, and basically that's all about, well, how will you actually build dApps in the Cardano ecosystem and deploy those dApps in a reasonable way with a great user experience? For over 3 years, we've been having these conversations, and we've actually had a small skunk works within the company led by a gentleman named Reese, managed by Darko Majic, the product manager of Daedalus. And they've been exploring basically a lightweight model that borrows from a lot of the good things that have happened in the mobile space, and they've happened in the web space, but also accepting the realities that these types of applications control your money. And if they go wrong, there's pretty bad consequences, and also a desire not to have a central curator. So the first instantiation of this effort is basically why we chose to use the Electron platform to begin with. We could have easily gone down a different direction that was a little lighter weight, but we wanted to have Node and Chromium in our stack. A, because these are huge projects that are super well maintained, and B, because all of the millions and millions of web developers who understand how to write software for these systems or have written software for these systems would instantly be able to apply all their tools, domain knowledge, and their capabilities into these systems. And there's a pretty reasonable security model around them. And in fact, in some cases, the security model is superior than the model we're seeing on the metal. For example, the WebAssembly CT effort for cryptographic implementations. It's just wonderful work that's recently been done. So we chose that model, and basically how generation 1 dApp development is going to work on the Plutus side is that you'll write your Marlowe and Plutus code for all of the logic that will go on the blockchain. Then you'll write something like Haskell for the logic that's going to go on the client side, or you could write that JavaScript. Then there'll be a way to go from that Haskell into JS or into WebAssembly, and then you can package it all together into a node package or something like that, and then bundle this as a single logical unit. That unit, along with an application manifest, so all that metadata, can be hashed and signed by your key, and then there'll be a registration process to take that unit that's been hashed in that metadata portfolio, so the author information, the version information, the fidelity hash for the thing, as well as the distribution information, either decentralized through torrent or in your servers, wherever you choose to host them, All of that is a little stub, and that stub can be put up on the Cardano blockchain. So then what the Daedalus App Store can do is look at that stub and pull that information right into a user experience like Google, almost like Google Play or the iOS App Store. But the difference is this is a permissionless system. So basically, anybody can deploy these things. There's no curator that is inside the store. Ordering will be handled in a fair way. And basically, there's no deplatforming or censorship in this type of a setup. The other thing is that you have a lot of really nice features. You have time stamping, you have a good PKI system as a result. You have a nice identity system that maps into this. It's easy to do automated updates because basically what you can do is uh, just update that stub to a new version. Daedalus can always check all the stubs, and if there's a new version, it says, oh, you have an update. And then you can also build a nice permissioning system in here about inter-app communication. One of the reasons we're moving to GraphQL is we're going to use GraphQL for the inter-app communication model that we have. So over time, it'll be very easy for the consumer to get a dApp. They just install Daedalus, and at that point, Cardano Wallet will be decoupled from Daedalus. So it means that when you install it, you can install it as a package in the system as opposed to this heavy infrastructure that we have. And then you'll have an app store built in, and it's just one-click install to be able to get your app. You say, oh, that CryptoKitties thing looks really cool. You click that, you get all the front-end code to interface with the dApp, and if you have a wallet, you can send funds to it and use it the way it's intended to be. And you'll have all those transitive dependencies will be built there, and then there's a nice reputation system that we can put on top so community curation can happen. So you could ask, well, is this a high quality app? Is an organization I trust, like Emergo or IOHK, for example, or the foundation, attested that this application is legitimate and it doesn't have any stuff in it that could be malicious, or it's just been misdesigned? Like if it's a lottery application, for example, is it a fair lottery? All the Plutus work we've done allows you to write correct applications, meaning that when you have the intention to do that, you can write it and get a high assurance that a DAO bug is not going to happen or the parity multisig is not going to happen. But it's still up to the developer to write what they want. And it's still up to the developer to decide the rules of the game. And it's entirely reasonable that people could deploy things that are not fair. And the only way to get over that is a curation component, meaning that somebody you trust has read the code, looked at it, and verified that this application looks fairly reasonable. Okay, so that's kind of the 1.0 model. And all throughout 2019, especially the second half of the year, we're going to be moving in that direction. It's a very nice model because we're basically saying deploy this stuff in environments constructed by some of the largest, most profitable companies in the world, with hundreds of companies supporting them in a very federated way. It's based on web standards. And so, hey, if millions of developers are happy with it, if big multinational companies are using these things, it's a good model to step up with. And then our innovation is going to be in the coordination and the organization, as well as the domain-specific languages to handle that blockchain logic. Furthermore, then we can add on service layers to the system so that the delegates, the stake pools, can double up not only just approving transactions, but then can run service networks like random number generation, data feeds, and other things, and offer these in kind of like a service-oriented architecture to dApp developers. And then you can just say, hey, that infrastructure is there. There's a toll for using it. And if an app chooses to use it, you have kind of a sustainable payment model. So the stake pool will go beyond just what are they charging to stake and look at more of a service provider for decentralized services to the ecosystem, and then people can consume them as they want them. Okay, so that's basically where we're at. We're moving real fast. We're real happy about the speed of things now. What's really nice is we're moving from super high technical debt code that really wasn't super well written to code that doesn't have any technical debt. That's based on specs, and it's exactly what we want. We know how to write specs. We've demonstrated that. We've taken a spec to market. About half our code's been swapped out to the new wallet backend. And we have a really good strategy for how to get terminal support, multi-sig, hardware support, how to get smart contracts into the system, asset issuance into the system, what that dApp development model is going to look like, and then by extension, getting interoperability with the Ethereum virtual machine and WebAssembly and other standards that are emerging in the marketplace, but while preserving a safe core to the system to ensure that the things that we use the base layer for are fairly well thought out, well designed. And Shelley is a spectrum, and we're right now in the beginning of it, and we're starting to roll it out. The fact that we've gotten here is a humongous milestone, and it's really cool to see all this stuff come together. And I'm really, really happy if that we've gotten this far. Building a cryptocurrency is a humongous endeavor. The vast majority of people who do it, they fail, and the vast majority of people who do it, they half-ass it. They copy someone else's work, or even if they invent something new, what they generally do is they cheat on the things they don't know how to do. So if they don't know how to write a consensus algorithm, they borrow someone else's, or a legacy system like BFT, and they say, I've innovated. And then what they do is they don't think about a holistic system. So they don't realize that design decisions you make in one part of your system, if they're not correct or if they're suboptimal, won't just be contained within that part of your system. It will cascade throughout your entire currency and inevitably lead to a death spiral once people take advantage of them, as we're starting to see with some of the incumbents in the altcoin space. So that's a long update. Sorry it took so long, but anyway, I'd like to get back to your questions now. Let's see what we got. There's probably a quite a bit of them, and since it's 12:21 here, I do have to go to bed soon, so I'm not going to answer too many questions. So Nostradamus asks, is a satellite staking pool a dream, or is it a possibility community members could buy a part of a satellite that will decentralize even more? So if you look at a logical breakdown of a cryptocurrency, you have the notion of a scripting language, you have a notion of a data layer. There's this idea of how does that ledger achieve a single source of truth that people can agree on. And then there's this concept of, well, how do I move things around? So, one thing is what can you do with it? How do you store it? How do you agree that what's been done is right? And then how do you inform people that you've done that? How do you move the data around? It's kind of a nice logical breakdown, and there's other ways to do it. But you'll find that most of the utilities of these systems fall in one of those categories. For example, scripting collects smart contracts. Proof of stake is within the consensus side. So this question is around the network side of the system, which is there is a concern that these systems are brittle because while we can build the perfect consensus protocol and the super secure scripting language, and we can have an idealized way of storing the data, so a perfect blockchain, if we can't safely use the client, the roads that the data runs on, the pipes that the data go through, those are in some way contaminated to either censor it or track it, then we really haven't accomplished very much. It's like saying, well, if the only way to use a cryptocurrency is to have to go through a centralized exchange and go through KYC AML, you're really never going to have a notion of a privacy coin because you can be private on the transaction level, but they know when you've exited and entered, and they can kind of fill in the rest of the history in between. So there's been a lot of discussions about alternative ways of transmitting data within your system. And one of those that Blockstream introduced, but by no means were they the inventor of this. This has been an idea in the cryptocurrency space for many years, I think as early as 2010, was the concept of could we construct a satellite backbone as a relay system? If anything, just to propagate transactions in blocks to guarantee that they couldn't be censored, especially in countries where there exists very aggressive things like the China firewall, for example. Now, as with all things, as with all technology, it's certainly possible to do a lot, but there's a cost benefit. And so the first question is, well, when you're talking about a satellite, somebody has to launch it, somebody has to design it, it has to run software, it's hardware. So somebody had to build it, and satellites have owners. So when you have those types of a system, intrinsically there are some points of centralization. Now you can kind of get around this if it's some sort of like federated ownership, or it's kind of infrastructure that lives in the ownership lives in politically neutral jurisdictions like Switzerland. then what you've kind of done is said, all right, well, yeah, I get that, but I've solved some of those problems through creative legal means or through federation. And that's certainly an interesting area to explore. Another idea would be making the cost of building these satellites, deploying these satellites so low that it's conceivable that small communities could get together, construct them, and then people could interface with them through some sort of like mesh of devices. This idea of micro or nano satellites with a pretty long runtime and reasonable uptime and low cost of deployment. If anything, if we could get 10,000 or 15,000 of them, I could go to SpaceX and buy out all the cargo on a Falcon 9, fill the whole cargo hold, launch it, and then suddenly we have a satellite grid all across the world. But you also can explore alternative ways of relaying data. For example, Project Loon from Google explored the idea of doing data through balloons. So basically, semi permanent balloons, and they would be put in strategic locations, and they would have functionally served the same role that a satellite serves, but they would be launched and maintained at several orders of magnitude lower cost. Now, I think with all things in networking, the key is to understand that you're not going to have a perfect solution, and heterogeneity is your friend. In other words, you need to have multiple models, multiple roads to run on. One of the key reasons why the internet's been so successful, hard to control, hard to censor for us, has been that it grew in a very bizarre way, in a very organic way, in a mostly unregulated way in the beginning days, where governments kind of understood it, but they didn't fully appreciate it. So a lot of things that they would have done while that hardware was being put into place and those protocols were being developed, like, for example, mandating identity be required to log on or things like that, they just simply didn't do out of ignorance. And as a consequence, the internet kind of grew up in a way that's very resilient. The other thing, the political realities of the internet was that you didn't really want a country to control it. So by necessity, you kind of had to agree to let everybody use it with some fair game. Now, this is being challenged because of the existence of gatekeepers like Amazon and Google and Microsoft and Facebook and other large companies who exert enormous control over all of the assets we tend to enjoy and use, and in many cases can track you even if you don't directly use their services, or vastly reduce your quality of service if you don't use the services. So I think it's important that we explore mesh nets, protocols like Open Garden and CJDNS. I think it's very important that we explore micro nano satellite ideas, and it's very important we explore alternative ideas like this Loon idea. It's pretty cool. And in the case of the economics of it, the cool part about our system is that these relay systems can actually be smart contract bearing instruments, meaning that they have open ownership, but to use them, you have to go ahead and pay a transaction fee, and that fee is paid to a contract. And then there could be a governance model connected to it, where that forms a micro treasury to maintain that unit. And as people are using it, it gets more and more money in the treasury, and eventually the device eventually is towards the end of life or needs to be upgraded. The device has its own bank account, its own money to pay for its upgrade, and that governance group can decide how to do that. You can come up with all kinds of creative competitive models. So I think this is something our space uniquely enables to occur, and it's naturally going to occur out of anything just competitive pressure or desire to make more money, or just because people get tired of being censored or controlled. It's a pretty good question. Yeah, so I see Mr. B says power issue here with Daedalus. Um, I don't do tech support AMAs, though I've seen a few people complaining about this. I'm not aware of any password issue with Daedalus. It would make no sense for that to exist. Uh, it could have been a situation where, for some reason, you had a corrupted state or database, or somehow a broken version of Cardano, of Cardano SL, and when you're upgrading from the old Cardano to Cardano 1.4, there was an anomaly, an edge case that our QA just couldn't reproduce. That's very specialized to your system. That the password did not get re-encrypted properly. We strengthened the encryption of the spending passwords between 1.3.1 and 1.4. So it is entirely possible that an edge case created some form of a corruption. The good news is that it's exceedingly easy to resolve this. The bad news is that That's a time-consuming process. You simply just delete your database, assuming you have it backed up and you have your keywords. You delete your wallet database, and there's instructions on the Daedalus Wallet website on how to do that, and then you restore your wallet. And basically, what this means is that the entire state of the system is reconstructed from scratch. And when you restore a wallet, that's password free because what the password does is it shields an existing private key family, but it doesn't live within the restoration process. So, when you restore, restore to an unshielded private key, and then you apply the password for encryption. These can be done at the same time, but you won't have anything to do with your old password or your old setup. So, if you're having a password issue, do send it to the help desk. We'll definitely investigate it because we are interested. In fact, we thought for a long time because the new wallet backend is a lot more sophisticated in many respects than the old one. Would there be an issue where passwords could potentially be corrupted, which would make it difficult for people to spend their money without going through a process? And we thought we hunted down all those edge cases, but it's very possible for a small set of people that there's just some weird thing that we couldn't have a broad enough imagination to see. And if that's the case, do submit a ticket to the help desk and Carl will take a look at it. And if you're real frustrated about this, you have two options. One, you can restore your wallet to Yoroi and immediately use it from the keywords, or you can delete the database and reset the whole thing and restore the wallet, and that should solve the issue. Okay, let's see what else we got. Okay. If CryptoKitties was ported to Cardano, would it be sizably better? Yeah, that's a really interesting question. So we get a lot of questions about the scalability of the system and exactly how much TPS do you need. And this is a very controversial and it's an often misunderstood topic. So my hope for where we can take Shelley is somewhere a performance between 50 to 250 TPS. So when we worked with Integer 32 and getting some preliminary benchmarks for Ouroboros prowess way back in the day, this was at 2017, they were estimating a greater than 200 TPS rate. So we said, that's great. This gives us a lot to work with because Bitcoin operates at a much, much lower rate. And this is about 30 times better than that. And for most networks, this seems to be, for sustained rates, a pretty reasonable load to be in. There are certain networks like the Visa or MasterCard network that need to operate at much higher rates, like 5 to 10,000. Okay. So we said that's a good starting point. And if we could achieve that, we'd be over the moon because it's already one of the most reliable, fast, well-balanced systems. But then how do we get to those big, sexy numbers that people really care a lot about? And first thing you have to understand is there's actually a couple of factors that are like a pendulum. They're not necessarily, everybody gets to have their unicorns and their money. You have to know that there is a trade-off between throughput and latency. The faster you want transactions to confirm, it's going to have some impact on the maximum TPS rate of the system. The more TPS you have, it is going to introduce this notion that settlement, this idea that you're confident the transaction has cleared, is going to suffer a little bit within a conventional consensus protocol. Now, this is something that people have heuristically understood for a long time, but we did publish a paper about this in a formal way, so you can actually really understand that relationship in a mechanistic way, a mathematical way. It's called parallel chains. And parallel chains was written by Matthias Fitzi, Peter Ghazi, and other scientists, and it's the very first step in the Ouroboros Hydra research agenda. So basically, we know all the common sharding techniques. That parlance has existed for a long time, and we know how to run chains in parallel. That's not rocket science at this point, and we know how to manage state between them, and we have a really good understanding of this. And not only do we know it, we also have our own process calculus we created. It's called chi calculus, And we have published, I think, a 70 or 80 paper. Wolfgang did that, one of our computational logicians that works with us through WellType. And knowing these things gives us a pretty good ability to deliver to market a very high throughput protocol. So if we want to get to 5 to 10,000, there's a road to get there. But then you have a conversation of, well, what does my network look like? What trust assumptions am I making? What am I giving up? How much Byzantine resistance is going to dissolve? And then there's a lot of little mechanics like inter shard communication and so forth that have to be worked out, which is why we also have this aggressive side chains agenda. So we're pushing real hard to get parallel chains and side chains to eventually converge together and become Ouroboros Hydra, which will be kind of the capstone protocol. Now, the idea there is that there's this concept that as you add more staking pools, more delegates, more people doing work, that instead of it being replicated, it's distributed. So the system will get faster with more users. So, and then you also have to decide, well, what does settlement look like, and what does throughput look like? Our belief is by layering protocols, you probably can offset some of these trade-offs. So if you're willing to accept some more federation in the system, then you can get super fast settlement and pay a special transaction fee for that. Or you can use the base network, get eventual settlement, pay a lower transaction fee, much higher throughput. So it can process a lot more work. Okay, so that's one dimension. That's the chain itself. And it requires some network innovations, and those are underway. And it requires some innovations on understanding these trade-offs and some tuning. So you start with Shelley, and 50 to 250 is our range there. Hydra, our targets are 5 to 10,000. We'd like to be in that range. Now, where does that get us? If we just get that alone, we're Visa scale. Realistically, that's a network that can process a humongous load, and most people be pretty happy with it. But we're not quite done because there's a lot of nuances in this conversation. One nuance is that we're just talking about dumb transactions. They're simple scripts. When you're talking about programs, stateful programs that are running long-term processes and they're very heavy, the validation time, the validation mechanics are more involved. And as a consequence, that looks more and more like a cluster of transactions as opposed to one. The nice part about the way we design Plutus and Marlowe is that because of these things and the use of the extended UTXO model, it's much easier to shard them, and it's much easier to actually understand how to load balance these types of things. And so that's less of an issue for us. But there's a natural avenue that the entire industry is starting to move towards with ventures like Starkware and Pinocchio and so forth, where people are saying instead of validating the entire program, just check some sort of proof that the program was correctly executed and that is indeed the output. And that'll be done off-chain, and the on-chain settlement is just verification the proof is correct. So we think that's going to be the long-term great direction to basically bring these things within constant bounds. Okay. Then there's also this idea of using layer 2 protocols like Lightning, for example. Yeah, there's just great innovation in that space. The RGB protocol and other things that are being put into Lightning. It's really exciting to see how fertile that space is, and there's great academic papers being written, great engineering efforts being written. And this is not a game for us of reinventing the wheel. The reality is that a lot of the complexity that's being introduced for Lightning is because they have an implementation target, which is Bitcoin. And so they're trying to figure out, how do I get this thing that was never designed to work with this thing to work? It's almost like you have an old motherboard in a computer, and you're just trying to rig it so that you can, without upgrading the power supply or changing the processor, somehow get your favorite graphics card in. Who knows if you can make that happen or not? It's not a system that was built for upgradability in mind, and as a consequence, it's very difficult to put it in, and have to do it very carefully, and there's a lot of value at risk. We have the unique advantage with Cardano of having kind of a multi-layered system already, in that we have stake pools. So you have this idea concept of these trusted 24/7 nodes that have reputation, people have delegated to them, and they have ways of proving they are who they are. So you have a PKI, you have a reputation, and you have an expectation of persistent quality. So when you move beyond just the service of maintaining the ledger, and you actually move to saying, hey, let's actually do other things, you can create a layer 2 network with those pools. And you'll notice something. We have 1,000 of them. That's how far we want to go. It's an enormously decentralized system, much more so than in any of these systems that are deployed. So what we hazard, I guess, is that we should be able to take these great innovations that are being built in the Lightning community, a lot of them now being formalized, some by Pramod and his guys at UIUC, some at Lightning Labs and other places, and pick best available, bring them in and add them as a value added service to stake pools. Now, what is the consequence of this? It means that for certain clusters of transactions, uh, micropayments for tipping, a lot of these things that you'd like to bundle together and process off chain. For those clusters of transactions, all those can be put into that layer two system because either the value at risk is lower or the trust bounds of running them in these systems is tolerable. And in many cases, they're even figuring out ways to anonymize things when they go into these networks so that the people processing these things might not even fully be aware of the transactions they're processing. So that's a very fertile area. And we think that that's how you get from 10,000 to 100,000. Okay, so if you look at protocols, for example, like TCHAN out of Cornell, Mingo and Sears protocol, their in the lab performance was 163,000 TPS on a production system using SGX. Great work, easy for us to bring that in when the time comes and layer with other solutions like adding oracles in and so forth. So the agenda for getting great performance is really three pronged. One is get Shelley out and then evolve Shelley to Hydra, which is really an iteration of the side chains and parallel chains research intersecting each other after we've done some more formal work on Ouroboros to get it to that state. And that gets us from the 50 to 250 to our target, we hope, of 5,000 to 10,000. This presupposes some more network enhancements, and we have a team that works on that. And then for complicated programs, and eventually all programs, try to get those to be represented as zero knowledge proofs that they've been executed correctly. That's the Pinocchio approach. Update, modernize that, and make that run off chain. So that basically you know it's run correctly, but the people who are involved in that are the ones paying those resources, and it's not slowing the system down exponentially when you have a CryptoKitties phenomena. And then for the really broad stuff, run that with a layer two solution. And basically, that's just a partnership in picking best available. And given the fact that we have ability to do much richer modifications to Cardano than Bitcoin can, it's much simpler for us to absorb that. And we have a natural set of trusted people within the system to run these types of services. So we have a huge advantage in both of those dimensions. It also will help us get interoperability with other systems. We have our sidechains protocol. We'll try to support other protocols like Interledger, but by supporting Lightning, when decentralized exchanges and all these other things go into those types of networks, it means all those currencies wired into that system we potentially can be interoperable with. So those bridges, that Internet of blockchains, that third pillar of interoperability for third generation blockchains, this is a great way of getting there. And it's just really nice to be in the same research pool as MIT and these other guys who really are taking this stuff very seriously. And there are millions and millions of dollars being spent on a regular basis, and with lots of great engineers, not just scientists, who are building practical production things and getting these things into circulation. So that's your spectrum, and those are the three areas of research we have. Markov Kohlweiss leads the zero knowledge side of things. He figured out a way to make an Ouroboros private. If we ever wanted to go down that road, it's called Ouroboros Crypsinus. It's always impossible to pronounce, all these Greek names. And we have him also working on a lot of zero knowledge stuff related to just these types of things, the off-chain verification programs, off-chain calculation programs, on-chain verification. And we have been parsing the Lightning world, and we'll be setting up a dedicated group the first half of 2019 to pick best available protocol and pull it into Cardano. And that should be relatively straightforward to drag out. Craig Wright invented Dan Larimer. actually, actually, it's one of the most awesome things I've read. Let's look for one or two more questions, and then I got to get off to sleep because I have a early morning meeting. Are you patenting? No, nothing that we do is patented. All the work IOHK produces is under either an MIT or Apache license, and we are patent free. Our written and video work is under a Creative Commons attribution license. So tell people where you got it from, but you're allowed to use it commercially or non commercially and share it with everybody. That's one of the value propositions of what we do. We're changing the science of the space, and it's the people's science. All those 40 papers you guys can take and use. In fact, I had dinner today with a Bitcoin maximalist. His name's Bob, and he thinks all these cryptocurrencies are scams, but he's a big Bitcoin guy. And we were talking about a wallet he's constructing for one of his clients, and I was mentioning he should use our UTXO spec, and also he should use our input selection policy that Edsco Van Rees created, because these things could be used in Bitcoin as much as they can be used in Cardano. And he's probably going to take a good look at that. And that's really the cool part of this field. We can borrow from Lightning and other projects when they come up with good ideas, but then we can pay it back by creating great ideas for other people to borrow from. And we all succeed together. Jiu-jitsu athletes in Africa and Brazil. When I was a kid, I did judo, and I'd like to get back into it, so I'm not so fat anymore. But I'm not a big jiu-jitsu man. Although a lot of my friends went into MMA fighting, and I went to a pretty crummy undergrad, Metropolitan State College of Denver. They even renamed it to Metropolitan State University of Denver. That was before I went to CU Boulder, which is actually a great university. CU is wonderful, but Metro's kind of it's got pride, man. And a lot of my fellow classmates who wanted to be doctors who didn't quite get in, they for some reason went into Brazilian Jiu-Jitsu, and there was like a whole club of them, and they've gotten pretty good because I'm getting old. Yes, is it possible to tokenize intellectual property rights on Cardano? That's the notion of a non-fungible token. So basically, what you would do is you would create a master token that represents a non-fungible asset, so like a patent. And then you have this idea of a vending machine style license issuance. So you would have a menu of license options, and each of those license options would have an address associated with it with a minimum payment. You would send payment to it, and if the transaction settles, the machine will vend a use token, and that use token would then be sent to say, okay, you now have the right to use this IP. Now, there are two ways of enforcing intellectual property rights. One can be just simply that idea that we have a two-sided metadata. You generate a lot of data with the transaction, and then you say in the terms of service that the only people who are allowed to use this are people who have purchased the associated license in this manner. And if there's a violation, you would sue somebody through a traditional court. Another way, if it's software, is by layering these solutions with trusted hardware. So basically, that's a DRM system. And so what you can do is say that that trusted token that gets vended, that token will only be vended to a hardware enclave, and that the software is built in a way that it will not boot unless that token is present. So it's like a DRM token. So this could actually be a way of handling video game distribution if the parent company has gone out of business. So let's say you've created, the world's greatest video game, like Baldur's Gate 3. It finally came out. They thrown a ball and did it justice. Right? And you go and release it, but it's not a commercial success. You screwed up the whole game. No one likes it. But you wanted to enforce some sort of DRM system. The hazard is if the parent company goes out, well, then if there's a DRM system that requires a server to start the game is now bricked. No one can use it. But if you have a system like this, that trusted hardware enclave can basically get a token from the contract, and that token was distributed from a decentralized infrastructure. So you have decentralized DRM. And actually, the first use case of this we think is going to happen with the Daedalus App Store. So you can introduce this idea of paid applications and layering Daedalus with trusted hardware. You would be able then to actually enforce a DRM schema for your games. So you can imagine a free and a premium version of a game like CryptoKitties, and to buy that premium version, or like skins or these types of things and have them displayed, you can have a system like that. This can be managed on a blockchain or it can be represented as a token, and then the token can go into the enclave. What's also really cool about this is it also gives you the ability to resell the license, and you can even have royalties go through that resale. So let's say that you're just done with it and you don't want to deal with it anymore. You can go sell it to your friend, and when it goes to their enclave, it records the transaction amount, and then 20% of whatever you've resold that IP for goes to the goes back to the parent contract. And what's really cool is that this can allow you to create limited license marketplaces, and you can have this kind of bidding war where prices can go up. So imagine a world where Magic the Gathering, for example, issued only a finite amount of cards for a certain set, and those were represented by a token, and that token lives within that trusted hardware enclave. Because it's within the enclave, you can enforce whatever transfer rights you care about that can't be hacked. It lives within a device that runs the code as written. Then every single time a person trades the card and sells it to another person, the parent company would get a percentage of that transaction. These are the kinds of business models you could create with that type of license. So it's really exciting to see what you can do with intellectual property, and it's really nifty. Layering it with zero knowledge proofs, you could even prove that you have a portfolio that has a market rate of X without necessarily revealing that. So, for example, you can imagine art marketplaces where you associate each painting with a verified token. You could verify that your total art portfolio is worth $500 million without revealing particular paintings within that portfolio to an outside auditor. And we talked to the art industry a few times about that. There's always people interested, especially here in Switzerland. They store a lot of very valuable stuff in this country. Go figure. The mountains are hollow. When can we expect support for Daedalus with Ledger? The problem with support on our end is we have to wait for Icarus style addresses to come. So that's coming with 1.6. They're being implemented in parallel with the decoupling, and the code will be probably feature complete by the end of the month. Then I have to go through QA, and we'll roll that out. Once we have those addresses, then it's pretty short order for support. It's more of building the infrastructure in Daedalus and a few little things here and there to get that in. So, rather than rush everybody and try to overburden the backend team, because they got a lot of Shelley stuff to do and APIs to write and so forth, what I decided is to kind of swallow my pride and let Yoroi be first in the market. It's almost like the gigahertz wars back in the day, where there was a race between Intel and AMD to get to 1 gigahertz processor. And even though Intel was a much larger, much more powerful company, AMD was able to sneak its way to that benchmark with a commercial product. And the same for 64-bit computing. AMD was the dominant standard. So anyway, Yoroi is maintained by a much smaller team, but they're really passionate and they work super hard. And this is their only thing to do. So they're working with Vacuum Labs. There's been a lot of progress already. And as soon as Vacuum finishes its job, it'll be very straightforward for Yoroi to add support for Ledger, because they already have a method to do that via what they've done for Trezor. So it's just flipping a switch for them with some other little things snuck in. So probably if I had to hazard a guess, I would imagine, unless there's a substantial delay from the third-party contractor or security flaw or something discovered, that Yoroi would be able to get that support in sometime in February. We're going to be a little bit behind them, and I will not imagine February support, maybe more March support, but it just depends on Shelley. Shelley takes the priority. I don't want to delay anything there. And if you already have one wallet that you can use a Ledger device with, then that's just an interface. All the security comes from the Ledger device, so it doesn't really matter if you're using Yoroi as the interface versus Daedalus as the interface. Some people would like to, but I care much more about, well, when you can finally use it with our system, you can also use it for staking, than just the mere use of it. It's just important to have at least one of the two wallets supported. And because Yoroi is focused on that exclusively, they're going to be able to beat us to market there. But I still hazard that we're Intel. My hope for Docker images would be as soonest would be February. That's my hope, and that'll be based on the Rust client that we have. I'm also trying to see if we can get our DevOps to push some things through some of the more common package managers. I'd love to see a homebrew Snapcraft and Chocolatey package, so you can just on Windows go Cocoa install, and then suddenly you have it. And the same for the other managers, Snap install and so forth. So we'll try to get that done. We reached out to some people in the community who are good at this stuff and have some spare cycles, and it's just a matter of me cutting them a check. Okay. I like the old style addresses. You can embed images of them, like David Hasselhoff, for example, on a jet ski, on a water ski. I'm looking for one good one. And thank you for the congratulations on IEEE Symposium on Security and Privacy. The person you really should congratulate is Dionysus. He's a graduate student, and this is his first paper, I think, to get to Oakland. And that's a major milestone for his career. Generally, you get in your postdoc years or postdoc years, and it's one of those things that helps you get a tenured position in academia. And to do that as a graduate student, especially given his life story, because he didn't start as a scientist, he started as an engineer, he worked at Google, and then he kind of came in a little bit late. He's in his 30s, and you don't really see a lot of people make that transition and do it successfully. There's a lot of things stacked against you. Research is a game of the young. So I am super proud of Dionysus and his great work. There's other authors on that paper like Peter and Agalos, but in particular, that's the one that's really special. Peter's much more veteran, and Agalos is much more veteran, and they got some great CVs already, enough to make people want to poach him. But Dio, he's a special kid, and he's going to have a phenomenal career. Already is having a phenomenal career. Could you give us an update on Cardano blockchain deployment in Ethiopia? Yes, I can. Okay, so basically, the class started January 8th. There are 24 or 23 students. Four are from, I can't remember the exact number. I think it's either 23 or 24. There are four from Uganda, and the rest are from Ethiopia. It's pretty cool in that it's an all-female class. This was a request from the Ministry of Science and Technology in Ethiopia. They have an initiative to try to get more women into engineering. And we said, well, can you give us qualified candidates? We don't care either way. And they said, no worries. And I think we had several hundred candidates who applied. So there was certainly no shortage of well-trained, well-qualified female engineers. We were a bit concerned that maybe due to the nature of their education system, that they would be underrepresented, but it was actually the opposite. It was a very competitive process, 5 or 10 for each slot. And Lars has just finished the first week of teaching, and they covered basic concepts in functional programming, and they're going to go all the way through everything in Haskell, including monads and how to do networks. And they're going to implement kind of their own peer-to-peer network, and they're going to implement a version of Bitcoin and all these super cool things. But it's our first class we're teaching where we're actually going to have a Plutus component to the class. So after they finish the Haskell component, they're going to do the Plutus component and do some cool workshop. And actually, because the IOHK Summit is happening in April, we may actually fly that class out because they'll be matriculated at that point, the survivors, because it is a very difficult class, and have them come out to Miami and do a presentation. So if you guys go to Miami to the IOHK Summit, tickets will start coming on sale, I think, in February, early February. Love to have you there. It's Miami, mid-April. I think the 17th and 19th. The website's up, though. The girls should come in there. Now, I've been asked a lot, well, how does this fit into our broader enterprise strategy? We have to learn how to teach people how to use the tools that we construct. And our tools come with a deep philosophy embedded. It's not about getting a million developers, it's about getting 1,000 good developers. Because when you have 1,000 good people who are very good at what they do, they can go build 10 or 100 good projects. And maybe two or three of them survive, but those that do become the Facebooks, the Googles, the Amazons that actually carry the entire industry. It's not about volume, it's about quality, and it's about experiences, and it's about unifying that holistic one-click install that the user has come to expect, and be able to have infrastructure that can support all of that. My job is to build great infrastructure and teach people how to use it. Their job is to leverage that knowledge and that good infrastructure to actually go and do cool things. So the purpose of entities like Emergo is once they're ready to go, to give them the resources that they need. Like they're already starting to do this with the Startup Accelerator in New York, and they'll expand that to give them the resources they need to have a shot. And the purpose of the treasury system is to also give them the resources they need to have a shot. So I want to make sure that the first crop of people coming out, instead of just guessing and reading tutorials and playing around with things until they screw it up, because 60% or more of the contracts on Ethereum have some sort of flaw in them that's not so good, that they actually know what they're doing. And so that means we got to get hands on, got to get dirty, got to go out there and train them in person. And we did that in Athens, we did that in Barbados, and now we're doing that in Ethiopia. The unintended consequence is that we like the developers so much, we've just been hiring them. We hired half of the Athens class, we hired most of the Barbados class, and there's actually code commits, and some of our best engineers are people we trained and brought up from the ranks, and they're making great things. In fact, the two Bayesian students showed up for the delegation workshop. That's pretty cool if you think that they started with nothing. One was a chemistry major at Oxford, and now he's a core developer for Cardano. So our hope is that this Ethiopian class will be able to master what the prior courses have mastered and actually make meaningful and significant contributions to the Cardano ecosystem. Now we're starting to exit the era of exclusive in-person training. We're going to continue doing that, but we're also pursuing partnerships to MOOCify all this content, massive open online courses, MOOC, MOOC, and basically take this and put it into the web and make it free and work with other partners so that they can make it free or at a very low cost, and then subsidize with the foundation regimen of getting 10,000 people through that extension into the system. So we'll have a core of extremely well-trained people that we trained ourselves that will have access to capital and either opportunity to work directly for us or in partnership with us or our partners. And then we'll have a constellation of lots of curious parties who have all that requisite knowledge to actually do some interesting things. And I think that's a sufficiently large set of people to populate our platform. If you look at the success of PlayStation or Xbox or any of these other systems, it's not that one system had huge amount of games on it and then suddenly that's the de facto system. You need that Red Dead Redemption, you need that Halo, you need the God of War, you need those bellwether games that just really stand out and people are like, wow, that is so amazing that I'm just going to go buy that platform. I'm going to get into that platform for that particular experience. And they say, well, since I'm already here, I probably should look at what else they have or add to it myself. So it's better to start with high quality and small. Now, we might have mistimed that, or we might have misjudged the need to have volume. And that's why we invested a lot of money into Ethereum interoperability. So all that junk on Ethereum could conceivably be ported over to the EVM that we'll having run on a side chain and its own black box to avoid it from contaminating the rest of the system. And then people can use their Solidity and their Web3 and whatever they come up with there. And if that's what they want to do, we have support for that too. And at least on our system, it runs faster, cheaper, and safer, and it has a much more coherent model. And it has an app store still that works with it, which has an easy and good user experience. So that's strategy there, and it's a long arc strategy, and they're working real hard. Some of the gals will be rolled over into the enterprise division, and we're going to be running some pilots. I could spend 2 hours talking to you guys about how cool enterprise is and how enterprise is going to drive adoption of millions of people into cryptocurrencies. But I've already been going for an hour and 30 minutes, and I'm tired. So that's for a different AMA. All right. Well, anyway, thank you so much for all your time, and I really appreciate it. This was a heck of a lot of fun. Good night, and I'll talk to you guys soon. Cheers.